Hello everyone. Good morning, afternoon, and evening for everyone who's watching this video. First of all, I want to thank you all for watching our video and took the time for it. In this presentation, I want to talk about our Capstone project, SmartPaddy. Well, let's get right into it. In this project, we have 7 amazing members that contribute to this project. 3 people from the machine learning team. We have Mursawal, Annisa, Auliya, Ramadhani, and Rahmi. 2 people from the cloud computing team, Febriana, Lingga, and me myself, Ville Kannisto, as the team leader. And lastly, 2 people from the mobile dev team, Bella Saharani Sopyan and Kelsha Aira Meylie. On to the next one. SmartPaddy is a smart application to detect rice leaf disease. In this presentation, we'll talk about the background of our project, the reason of choosing this project, the existing results to compare our project with, and lastly, the implementation and documentation of our project. Well then, let's get started.
Okay, I'm Annisa. I will explain the background of SmartPaddy. The impact of climate change. According to research from the Badan Riset dan Inovasi Nasional, climate change triggers an increase in the number of pest attacks that damage paddy. One of the pest attacks that has occurred is the prone hopper, as reported in the news. This pest attack occurred during the long dry season, from June to August, which leads to a decrease in production and even crop failure. Next, farmers often take incorrect action in dealing with paddy diseases due to a lack of knowledge in detecting and taking the wrong actions. This lowers productivity and affects the livelihood, solving the need for technology and based solutions to improve disease identification and management.
So the next is reason. Why do we take the topic of agriculture, especially regarding to the rice cultivation? So the first is rice is the main agricultural commodity for the Indonesian people. And then the second is mistakes in identifying disease can reduce rice plant productivity and also increasing the risk of pest and disease. Not only that, Indonesia has a great potential to increase the rice productivity through the technology adoption. 63% of the energy needs of the Indonesian people are mostly obtained from rice, making it the main source of the carbohydrates. We also committed to supporting sustainable agriculture by providing fast and accurate rice plant disease identification solution, so farmers can take timely action to save their crops. Why SmartPaddy? SmartPaddy has a real-time analysis, has a recommendation of the right solution, and also easy to use for the farmers who may didn't understand about technologies.
At this point, I will explain the section about similar apps. We compare two applications that are similar to ours, is Rice Solutions and PenSnap. We evaluate their performance based on 4K feature to highlight the strength and weakness of each app. Let me guide you through the details. First, we analyze detection accuracy. Among the three, SmartPaddy is the only app that excels in this area, ensuring reliable detection, while the other two fall short. Next, we consider the explanation of disease. Here, Rice Solution and SmartPaddy perform well by providing clear explanation, whereas PenSnap does not include this feature. Then, we look at handling recommendations. This is a crucial feature, and only SmartPaddy stand out by offering actionable steps for users. Rice Solution and PenSnap do not provide this functionality. Finally, we evaluate the user interface. On this point, all three apps offer user-friendly design, ensuring easy of use for their users. In conclusion, SmartPaddy leads the competition by providing all the features at 100% coverage, making it the most comprehensive solution compared to the others.
So the next slide is implementation and reasoning. I will explain about the implementation of machine learning in this application. Several tools and libraries are used during development including Python, main programming language, VS Code for writing and management board, TensorFlow for designing and training models, Jupyter Notebook for data visualization and experimentation. Now, let's move on to machine learning workflow in this application. Data exploration. In this phase, we understand the data by identifying pattern, evaluating data quality, and ensuring that the data is relevant for model building. Data preprocessing. In this phase, the image are resized to uniform size, such as 224 by 224 pixel, to ensure consistency. Then the dataset is divided into 80% for training and 20% 20% for validation, where the training data train the models and the validation data is used to test its performance. Modeling phase. In this phase, the model is trained to recognize pattern, color, and shape from the image data. The model learns unique features such as leaf shape, color variation, or disease damage pattern. So it can predict whether that plant is healthy or diseased. Training and testing the model. The model is trained using the training data and tested with the test data to assess its performance on new data. The evaluation results include metrics such as accuracy, precision, recall, and F1 score to ensure the model is performing well or needs improvement.
Okay, for the cloud service, we use Flash for our API, Google Cloud Run for API deployment, Cloud Firestore for database storing, and Cloud Storage for ML model and image storing. For the implementation, our system begins with user interacting through an Android application. The Android app then communicates with the backend API deployed on Google Cloud Run. The API interacts with our machine learning model. To optimize performance, the model is stored in a cloud storage bucket, which provides secure and high-speed access to the API. Once predictions are generated, the results are stored in two ways. The first one is Firestore, for storing structured prediction data such as analysis result. And the second one is Cloud Storage, where we store the prediction image in a separate cloud storage bucket for efficient handling.
For the mobile development, we use three mobile tools such as Figma for making the expected UI, Android Studio for making the app and integrate with the API that given from cloud computing team, and GitHub for manage the code. Here's our implementation design. We have login and register page, home page, camera, profile, detection history, also its details. It's our team documentations for the API and model. And 90% of the documentation is in line with the final result, including the tutorial for implementation to deployment. For the deployment plan for the next 6 months, we'll starting with first, more SOP development for dataset. The second one will be CI/CD implementation, and the third one features for treatment based on climate conditions and natural disaster, and the fourth one is GCP credits.
Okay, now let's start our demo of the app. So first we're going to log in with our existing account, and then after that you can start to analyze. We're picking the picture from gallery, and then you can see the result in the history page, and this is the history detail page. And then you can try our dark mode feature. You can see that the UI is the color is changed, and then you can, if you're finished, you can log out. And then next, we're going to talk about SmartPaddy's market size. Let's start with segmentation. SmartPaddy focuses on Indonesian rice farmers, especially those who depend heavily on their harvest for income. These farmers often face challenges like pests and diseases that can damage crops. What they need is a tool that helps detect these problems early and that provides effective solutions. Now let's talk about targeting. Our main audience is farmers aged 17 to 55. They could be individuals or part of farming groups. What makes them stand out is their openness to adopting new technologies that can improve their crop yields and productivity. Finally, how do we position SmartPaddy? We aim to present it as a reliable, innovative tool that helps farmers quickly identify and tackle pest and disease issues. It's not just about solving problems, it's about making farming easier and more efficient. And then I'm going to talk about SmartPaddy's SWOT analysis. First, the strengths. SmartPaddy uses innovative technology to tackle farming challenges, and it's user-friendly, so farmers can use it easily. Plus, it directly supports local farmers, helping them improve productivity and livelihoods. For the weaknesses, SmartPaddy depends on data quality, so inaccurate input could affect results. Another issue is limited access to technology in rural areas, which could limit adoption. On the bright side, there's big potential to scale up, reaching more farmers over time, and with the growing agri-tech market, there's a lot of room to innovate and expand. Finally, threats. Environmental risks like unpredictable weather could impact how the system is used, and some farmers might be resistant to change, which could slow adoption. And then that's all from Smart Paddy. Thank you for watching our presentation. Have a great day.